Assalamualaikum warahmatullahi wabarakatuh. Hello guys, back again with me. My name is Hidayat. In this video, I want to tell you about development stomata. And then, do you know what is stomata? Stomata are epidermal valves that are important for plant survival because they control the entry of assimilated carbon dioxide in photosynthesis and optimize the efficiency of water use. Stomata originates through a series of divisions that produce stomata spacing patterns, control the frequency of stomata, and produce two valve protective cells. Stomata is produced after a series of cell destinies chain with each precursor cell undergoing a particular cell division program. Each asymmetric division produces a merstomoid and larger sibling cells. And the next question, does stomata has a pattern? Yes, stomata has a pattern. Although stomata destiny varies, nearly all stomata are separated by at least one impression cell. The distance of this one cell is probably adaptive in producing a dissolved reservoir between stomata, in minimizing mechanical interference between adjacent valves, and in optimizing the distribution of those division cells. A space platform appears when a new asymmetrical division occurs next to an existing stoma. And the last, how stomata grow develop, the gain that act early. These gains, which consist of presome receptors, processing protease and kinase, act primarily by modulating numbers and placing asymmetric divisions in the stomata cell lineage. Stomatal patterns by negative regulations. All of their earlier working gains are widely needed for stomata number, distribution, and patterns. However, the cellular mechanism by which these genes control the development of stomata can vary. For example, the MM and SDD1 directly produce patterns by orienting spatial division, while pattern defects may be a secondary consequence of transformation of cell fat in the Yoda mutant. The genes discussed in this section encode proteins that are predicated to act in inter and intracellular signaling. Basically, they act as negative regulators of stomata formation. Several transcription factors are identified that actively promote the development of stomata at entry, proliferation, and differentiation. Lead-acting genes. After asymmetric divisions initiate and populate cell lineage and establish the spacing pattern, the developmental program changes to symmetric division and terminal differentiation. Genes known to act during this later stage help and cell proliferation, execute GMC cytokinesis, and regulate the timing of guard cell specification and differentiation. And cell proliferation. And cell proliferation, a common feature of eukaryotic cell lineage is that the precursor cells divide a finite number of times and then differentiate into specific cell types. The symmetrical division of GMC is the last division in GMC stomata cell lineage. The daughter produces mature cells into a guard cell that withdraw from the cell cycle in either G1 or G0. The relative time of withdrawal of the cell cycle and the specifications of the guard cell have not been established. However, ending the previous cell cycle of terminal differentiation seems to be very tightly regulated and adaptive to valve functions because the stomata in almost the plant taxa because the stomata in almost all plant taxa comprise only two cells. Three suspected transcriptional regulator for lips are FLP, MYB88, and FAMA limit the cell cycle at the end of the lineage stomata. Mutations losing function in FLP induce groups of cells that are laterally aligned to the original clonal. This cluster results from repetition of the GMC program in Indonesian daughter cells which cell normally differentiate directly into guard cells. Excess divisions delay rather than blocking stomata specification because clusters contain normal and captured stomata. FLP encodes the MYB-R2-R3 protein whose expression begins before GMC mitosis and is then regulated as a differentiated guard cell. FLP limits GMC to only one symmetrical division and promotes a timely transition to terminal differentiation. I think it's enough for now. I hope you enjoy this video. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.